welcome you to the webinar, and in the spirit of reconciliation, the Statistical Society of Australia acknowledges the traditional custodians of country throughout Australia and their connections to land, sea and community. We will pay our respects to their elders, past and present, and extend that respect to all Aboriginal and Torres Strait Islander peoples today. The two speakers we have are going to share the topic. I'll give a very briefly. Anders Holmberg is the Chief Methodologist at the Bureau of Statistics, and Dr. Rajeev Samarage is the Data and Analytics Lead at the Melbourne Institute of Applied Economic and Social Research within the University of Melbourne. I will leave their backgrounds in information that you have already and hand over, I believe, to Anders, who's going to give the talk. We will take questions at the end. The talk should run for about 40 odd minutes. If you're interested in putting a question, please put it through the chat, and I'll put the questions at the end to the speakers. Thank you. Anders, if you wouldn't mind commencing.
Thank you for that, Stephen. I hope you all can hear me well, and I also like to thank the Statistical Society for putting this together. So it was actually a joint effort discussing on how the ABS and the SSA could collaborate through a series of webinars or seminars that we were thinking in the beginning. And one of the topics that was up there was data integration. So this is and early on we realized that, you know, it's such a big topic, so we might have two. So this is the first in a series of at least two about data integration. So I also want to thank you for joining me up with Rajeev and the Melbourne Institute to talk about these topics that we're going to bring out today. So it's going to be an introductory webinar, and we're going to use a relatively complex research example to illustrate how a question in the title can be addressed. So we have a few highlights. So we want to have systematic approaches to a certain good research design and improve the quality in a data integration setting. Especially collaboration between and development between data producers such as my organizations and users of data is another one of these topics that we want to address here, and perhaps have a few share a few thoughts and get some inputs also on how this could be improved. And also another thing would be sharing information about research opportunity that exists in the data integration space, which is kind of one of the things that I'd like to have out of this series, to get more collaboration in this area, because there's quite a lot of it, and I think that it's one of the, you know, ever-growing areas that we need to do a lot more, and I hope we can illustrate a few of those things today and in the next webinar that is coming up in a month or so. So keep an eye open on those things. So next slide, please. The outline is barely this. We're going to, you know, give a short introduction of the research study that the Melbourne Institute is doing. I'm going to present a bit about the trade-offs, what would happen when you typically have multiple input data sources, and a very, what I think, quite useful quality framework around that. We're going to talk about the data sources in this particular study, the issues when we use these quality framework, which has been a very good pleasure to, you know, discuss together with Rajeev, and finally we will talk a bit about good practices and so on. So that's briefly the outline. So next slide, please. So the subtitle here was the case of researching economic disadvantage in Australia. So why would you look at that? Well, obviously it's an important topic. It's the highest on the list. On, you know, poverty is one of the highest things on the list that the United Nations is reflecting on, and it has it as the #1 goal by 2030 to decrease the poverty in the world. The Melbourne Institute is doing a number of different stories and research and so on, and obviously, as you see here on the slide, that a recent study showed that a contraction of 5% in the economy as a result of the COVID pandemic might, obviously increase the poverty and the income-based poverty for the first time since 1990 in Australia. So this is a very important topic. It's also multifaceted, and the work that the Melbourne Institute is doing now has basically three very complex or typical goals. One of them would be to study the role of geography and patterns in migration that affect the identification of communities that have a large share of household in poverty. Another one would be the financial and socio-demographic patterns of individuals and households that are confronting persistent, cyclical, entrenched disadvantage, and how these patterns can be, followed across communities and across times. A third one would be to study disadvantage across generations, and clearly these three things are very, very complex issues that is pretty hard to study in depth, and it also requires quite advanced quantitative analysis and a quite advanced research design. Next slide, please. So the question would be, can you run a survey to, study these things? And if you can't, why not? And obviously you can if you have a lot of resources, and if you have an organization backing this up. And of course, one of the things would be around getting the longitudinal aspects into these things. But stepping back a little bit, the obvious thing from a researcher's point of view would be to start looking on what data is already out there and what data can be reused, and what can you do to complement these. And this is kind of where we're coming from in this seminar. So typically what we would be looking at is research designs that are observational or non-experimental. So they could be descriptive, or in the research, from the research point of view, often an explanatory purpose behind these things. And the main argument, I would say, for not trying to run a survey would be cost things, because collecting data in today's world, it's a science of its own, trying to avoid all the issues that comes with non-response and other types of errors that appears. It's a competition out there. There's a lot of provider burden going on, and joining up with organizations that have data collection or data acquisitions as one of their main businesses would be, quite useful, or reusing already existing data, which might be administrative data, or it might be survey data. The disadvantage in this, of course, would be you're not in control of what you're collecting or what you're getting. So you wouldn't be completely sure if there are confounders in your research design. You need to be assured about internal, measurement validity, or external validity in the sense of how representative is the data to other populations. There are, of course, issues such as consistency and reliability that also will come up when you reuse the data that somebody else has connected, or other data. Next slide, please. So in the survey world, in my mind, a pretty useful framework has been a framework called the Total Survey Design and Total Survey Error Framework. If you look at the picture to the right there, you will see it divides the survey process into two parts: the measurement part and the representative part, which has variables and units. And then in a typical statistical way, you kind of move yourself through it and you pick up all the errors along the way. And finally, you have a survey statistic that might be, good or bad, depending on how many of these errors that you picked up. This has its roots in the 1960s. My scientific grandfather, Ture Dalenius, spoke about total survey design very, very early. And it's been developed ever since. And I would say that the picture to the right here comes from the book by Gross et al. but there's been also a number of other, it's a rich literature around this total survey error and things. And especially interesting is the Beamer et al. Thing, which uses the total survey error things to really assess quality from a producer perspective, like ABS or other statistical agencies. I think it is typical of this area that it has had a producer rather than a user perspective, and the producers in this case would be big survey organizations, often official statistics that has used it in the sense of improving their processes and improving their output and communicating the quality of survey statistic. It's not until the recent past that other types of sources than sample surveys have been kind of looking at this way of stepping through the process, and there is some literature there as well, and one of them would be the framework that we're going to talk about today. So I think that is one of the points here, you know, meeting the producers with the users, because from a producer perspective, you don't necessarily think about that data might have a second use or a second life, as I like to call it here, and that's also what we're kind of looking for when we go into data integration process, or when we reuse things like administrative data, or what is popular today like big data and so on. Next slide, please. So there are a number of questions which will happen when you have multiple data sources available for your research question. One of them is, of course, the entities or the units that you use. Another one would be the concepts that actually comes from reusing somebody else's survey data or admin data. Do these things meet the requirements of your research objective, or do they interact in a strange way, which they usually do? And I think that the framework that we're going to show is a good way of stepping through and finding potential pitfalls and so on and those things. You also have to ask yourself whether administrative data that you can't control are useful. And you also need to see whether you can observe or actually assess the quality of such data. And that comes down to how much documentation the producer actually has done, such as, you know, it could be an administrative data source or something, or a survey that the ABS has done or something like that. And finally, as a researcher, you have to ask yourself, is it an advantage to utilize several data sources, or does it just make things more complex? So that's kind of the things we're going to look into. So what we're studying here and what we're going through is to use the research objective that the Melbourne Institute has, and looked at this quality framework by Li-Shun Zhang. So next slide, please. You'll see the first part of this quality framework. So this is what Li-Shun Zhang actually does, is that he brings the total survey error model into two phases. So the first one would be for a single data source, very much similar to the ones that you saw in the previous slide. It goes through the same types of steps through measurements and representation. One big difference here is that the representation side is called objects, and the reason for that is that it isn't necessarily the units of interest that comes with the secondary data source that is being used. So Li-Shun Zhang choose to call it objects at this point of time. Otherwise, there is very much similarity with this first phase as it is with the original one from the previous slides from Gross et al. However, the terminology here is adapted to reusing, for example, register data or administrative data of various kinds. What then happens is that the output here is a single source microdata set. It's not the survey statistic. And the reason for that is that this one then goes into phase 2, which is on the next slide. So in the phase 2, you have a set of input single sources and integrated microdata of various types. And what happens here is that there is another set of errors that comes into play. So these errors, they are results of the data integration processes that you do. And the important, or one of the important differences here is the transformation from objects to units. So when you have secondary data sources, these objects, obviously, they come from a different purpose than maybe your research objective is. So in order to merge these or integrate these data sources with one another, you need to transform them, and that's the thing in the second phase where Li Shunshang suggests the change into unit. And this could be for many different typical cases. I mean, obviously, administrative data often are registered events of various types. So it might not be a household or a person even, or it might be different sources that are persons and households or dwellings, or all these kinds of different adjustments that you need to do to get an integrated secondary microdata set, which is the output here, which you would be set to do the analysis that is in line with your research objectives. And for Australians, I think one of the things here as well that is of interest is that in many areas around the world, the census is actually the result of a process that looks like this. It's a hybrid of directly collected information and information that is picked up from various types of administrative systems that exist in the society. So it's a very generic model. It's hard, of course, to get a final single number of all the errors that are in here, but it's very useful way to actually step through and see where the trade-offs between various types of errors might exist when you integrate data. So with that said, I'll hand over to Rajeev, who's going to talk a bit about how their research project could be seen in the light of this framework. So Rajeev, please.
Thank you, Anders. Mark, if you could go to the next slide, please. So over the next few slides, I will walk through a simple example from a project that we just recently completed at the Melbourne Institute. So we're interested in studying disadvantage and cycles of disadvantage among individuals, families, and households in Australia, as Anders mentioned. Cycles of disadvantage relates to how we observe Australians transition into and out of poverty. And in some cases, especially when we look at the extreme poverty and we observe an entrenched pattern where individuals cannot get out of poverty. So we approach this study by looking at what data sets are available out there for us to use. And in this particular case, there is a limited amount of open data sources that can carry the analysis to answer the questions we laid out earlier. Another potential data source is to conduct our own survey to obtain the measures we need. As Anders mentioned earlier, this would give us the best data set since we can exactly target the population we need at a unit level we require and formulate the variables and the data we want to capture within it. However, the downside here is time. For years of planning to set up the survey, conducting the data collection, and conducting data preparation just before we're even able to get to analyze the data we want. To that end, we looked at data sources that are currently available. So candidate number one is the Census of Population Housing, I guess also known as the census by the ABS. It's an excellent and obvious choice as it provides the best coverage of the population in Australia. It has excellent geographical coverage and has a range of demographic and income measures, including details on family structure. One of the downsides, however, is that it is only captured every 5 years. There are two distinct products available from the ABS that use the census. There is the cross-sectional census that provides data for households and individuals for a given year in aggregate form. Then there is the ACLD, or Australian Census Longitudinal Dataset. That's a mouthful. That is microdata for individuals linked across 3 censuses. Then there's candidate number 2 is a Survey of Income and Housing, or SI, which is also conducted by the ABS. This is a detailed survey that collects data on demographics, housing, labor force characteristics, education, income, and assets. It too has a great coverage of the Australian population and has been conducted every 2 years since 2003. This data set actually has some single time points available and goes back as far as 1969 when it was called the Income Distribution Survey. Candidate number 3 is I like to call it the Survey of Income and Housing's longitudinal cousin, the Household Income and Labour Dynamics in Australia, or HILDA survey. HILDA, which is produced by the Melbourne Institute for the Department of Social Services, has been running annually since 2001. It too has great coverage of the Australian population, spanning approximately 18,000 individuals and approximately 10,000 households. The benefit over HILDA over PSI is that the data collection is longitudinal, with repeat measurements captured for the same sample over the last 18 years. This allows for longitudinal tracking of individuals over the years, including capturing changes in family structure, change in employment, and outcomes of the children of the individuals in the sample. Candidate number 4 is an administrative data set from the Australian Taxation Office. This data set is called the ATO Longitudinal Information File, or ALIFE, and consists of a 10% sample of individuals from the ATO client register. ALIFE captures information from lodged tax returns yielding annual longitudinally linked individual tax and superannuation measures. The current release of ALIFE tracks the individuals from the 1990-91 financial year to 2015-16. Its longitudinal time span for data capture and large sample size opens up new opportunities for research across many policy domains, and I'm including this work here. Next slide, please. Based on some of the different aspects across datasets, there's no one true dataset that covers the breadth of the measures we need to answer all of our research questions. The cross-sectional census provides immense statistical power due to the number of observations, but it is a much simpler dataset when you look at this matrix of complexity from a user point of view, actually. So this matrix captures the number of measures on the y-axis, which is the complexity of the dataset, and the number of observations or statistical power on the x-axis. The census has excellent coverage across all geographic definitions that we use, and it allows for deeper data insights, especially at the smaller kind of community level we're interested in. PSI and HILDA both provide similar measures, but a range of measures captured at the household and individual level. ALIFE also provides excellent statistical power due to its sampling methodology. However, the data is not as complex in terms of measures obtained from targeted surveys such as HILDA. This plot highlights some of the differences in our case between what we would capture through a targeted survey versus data obtained for administrative purposes. Next slide, please. Choosing the appropriate data set also requires us to think about the units, or I guess, as Anders mentioned, we study. So a useful exercise to carry out at this stage, I guess with any project, is to start with a data mapping exercise where we map the data sets to the measures we want, how we integrate the different data sets at what level. This is something we will take very seriously, and documentation, preparation, this helps us along analysis. But in some cases, in most cases, we are unable to link data at an individual level due to potential privacy impact implications. For example, the census only provides aggregate measures for populations and subpopulations across a range of statistical geographies. The ACLD, HILDA, PSI, and ALIFE all provide individual measures, but across differing statistical geographies. For example, the lowest geographical level ALIFE provides is SA4 because of existing legal requirements set under the Privacy Act. This raises concerns when we wish to integrate the data to answer a research question. So one method is to integrate the data across geography with the linking conducted across the same statistical area. However, there are limitations as we risk adding noise due to statistical errors with the use of with smaller areas. We observed this recently when we were using ABS Table Builder, as it performs a statistical perturbation to the data before it's released. Now, this perturbation results in larger biases when numbers we deal with are much smaller, as you encounter in smaller geographies. The other downside I should mention is when you have to map across multiple geographical definitions, is you have to take care when you're mapping across standards, such as the ABS went through a standard change from 2011. Thankfully, we do have correspondence tables to help with this. Next slide, please. So units is one important thing. The other appropriate thing we need to think about is the population we study. Now, this is especially the case when we deal with administrative data such as A-Life. This is a plot from a working paper by Kane Polidano, a senior researcher from the Institute, and our colleagues at the ATO. It shows the distribution of individuals in the data set by age. The ATO client register distribution, which is the sampling, which is how the A-Life data is sampled, is a solid black line all the way at the top of the chart. The ABS population estimate is provided by the dotted line. First, you can see that the client register contains far more individuals than the ABS estimate. This is due to additional records captured by the ATO on these individuals, foreigners, and citizens who are likely to be overseas. The blue graph represents individuals who have lodged their tax returns, and the green one represents what we call non-lodgers. They're individuals who have not lodged their tax returns, but data is filled using data provided by employers and other organizations. A-Life, I guess, as you expect, is it captures the working population very well, but there are differences between the ABS estimates and A-Life on capturing individuals that are outside the working age. This is a very critical point to understand, as this sort of detail would affect our analysis and how we answer our research questions. For example, some of the most disadvantaged subpopulations are students and the elderly, which we would not capture well through A-Life. In this case, we would have to reformulate our research question to perhaps study individuals participating in the labor force that are experiencing disadvantage. This shows that the understanding of the unit of each observation and the coverage of the data set is key, and it needs to be undertaken prior to analysis. For more detail on the analysis behind this chart, I refer you to the working paper by Polidano and authors as shown on the page. Next slide, please. The key measure of interest to studying economic disadvantage is income. It can be argued that disadvantage comes in many forms, but what we contextualize as disadvantage experienced by an individual or household is more often driven by the lack of economic resources available, which is income. So all three data sets capture various income measures, which include labor income, wages, salaries, and overtime, business income, which is through profits or losses, dividends from shareholdings, interest, rent from investment properties. It also captures government pensions, benefits, and a range of other welfare payments. However, A-Life would not capture non-income support payments. And the other difference is that HILDA captures irregular payments as well, such as redundancies and compensation. But this is what is captured, but not how it is captured. For example, on the next slide, one of the issues with income measures with census is that the income measure is an aggregate measure of all types of income, while A-Life and HILDA contain individual components. This is evident in how the census asks a question on its census household form. What is the total of all income the person usually receives? There are two issues evident here. One is the use of brackets, which is done for confidentiality reasons, and the other is the term usually, as this results in recall error in the estimate provided by the respondent. This is not the case with a survey such as HILDA and SCI, where exact numbers are recorded by the interviewer, and usually individual income components are captured that are then used to determine the aggregate measures. With A-Life, the data as captured on individual tax return allows individuals to write the exact number down. However, nowadays, most of this data is pre-filled, which will provide it the most accurate measure. Next slide, please. For poverty calculations, we often require the median income for the population or subpopulation. Individuals or households are classified as in poverty if their median income is less than 60% of the median individual or median equalized household income. Extreme levels of poverty are usually classified as incomes below 25%. But determining the median income using a probability distribution of categorical income variables is tricky. One method is to perform a simple interpolation step on the cumulative distribution of the data, which we derive from the frequency distribution. There's lots of work done on this in this space. There's lots of interpolation functions we could use in this. This allows us to easily determine median incomes for a various range of subpopulations. You know, this could be for males, females, single households, couple households with children, or I guess from a specific geographic location, such as, I don't know, all one-parent families living in South Yarra in Melbourne. Other issues arise when analyzing individual data too, especially in the event that the previously mentioned poverty line is also inside the income bracket. In these cases, we resort to using a predetermined point in the income range, such as a midpoint. But you also need to take care in and perform some sensitivity studies to ensure that the position you pick compare well to state or national level statistics. Next slide, please. So here is an example where we used cross-sectional data to determine community level poverty rates using some of the methods I described earlier. Shown here is a map of Australia with the geographic boundaries depicting SA2 regions. These regions, based on their sizes, do represent a community that interacts together socially and economically, and a population ranges between 3,000 and 25,000 individuals. The colors here represent the share of households within the community that are in poverty. So black and blue represent communities that have a low poverty rates, while communities with yellow represent communities with higher poverty rates. This allows us to overlay different demographics and measures at the same community level through analysis and provide flexible data visualization options. It also provides the capability to conduct space-based analytics to determine the correlation with other place-based demographics and poverty indicators. Next slide, please. Another thing we could do is to conduct a temporal analysis, which we've done with this recent study. And here we classify communities based on the share of households in poverty within each community. The alluvial chart on the left-hand side shows how the rankings of communities based on the share of households in poverty change across a 10-year period from 2006 to 2016. Now, it's a bit back to front, this chart. The top 20% refers to the communities that are in the top quintile for communities experiencing disadvantage, so the most disadvantaged communities. So blue colored flow describes communities that are entrenched or stay in the same ranking over a 10-year period. Red describes communities that are increasing in ranking or increasing in poverty rates, and green describes communities that are getting better. This interactive visualization with an accompanying map allows us to visualize which communities follow which patterns and interact with the data to see communities and their classifications for all of Australia. It also allows us to explore socio-demographic measures for specific communities and community classifications. So this GIF, I hope it's coming through well for you guys, provides a view of how we can interact with this data. We anticipate to publish this interactive visualization in the Melbourne Institute webpage in the coming weeks, and the work will also be covered in an upcoming report from the Institute as well. I will now hand you back to Anders to provide conclusions and a future outlook.
Next slide, please. Thanks, Rajeev. So I mean, to me, it's quite obvious that the answer to the title question, especially when you have complex research objectives like the one Rajeev and the Melbourne Institute is doing, is a clear yes. But at the same time, it's also quite obvious that there's a lot of things that you need to consider when you go through these things. And the quality framework that Chang had put up kind of shows you and gives you a very, very useful way of being able to identify trade-offs. And when it comes to data integration, there is a whole heaps of various ways of doing these things, which might be have advantages and disadvantages. I mean, in principle, you can combine data in a number of different ways. You can do them with unique identifiers, which is relatively straightforward if the original data has good coverage and so on and so forth. If you don't have unique identifiers, you can do it without, which is often the case in countries such as Australia and on the population side. You can integrate through communal objects, usually through time and space, which Rajeev just showed how they do it in this particular study. But you can also do it through common concepts such as semantic web objects and so on. And that's one of the research areas that we're looking at right now in the ABS. It's still nascent, but it's obviously something you can do. Many times it comes into composite units as well, such as households or enterprise groups and so on, and you might have to satisfy yourself by doing that. And that's another one of these things that needs to be taken into account if it is good enough for the research object you have. And on the second bullet item there, I think there is a lot of things that we can progress as a research community, both on the producer side, such as the ABS and other producers of data, but also, meeting the users, such as the Melbourne Institute in this particular case. Over a decade ago now, I got involved in Statistics Sweden's Microdata Online Access program, and that's when I got the interest and actually saw that the way we were looking at things at Statistics Sweden at the time was completely different from the user's perspective, wanting to reuse various types of integrated data back then. And it comes down to metadata, it comes down to documentation, and it comes down to how things actually fit a secondary or another new objective to reusing the data. And there's a lot of things that we can go through. We will have the classical things like selection biases, measurement errors, things on how they interact with, how we aggregate and how we actually can integrate the data. And I think Chang's framework actually illustrates that in a good way if you step through it in a systematic way. I also think that there is a need for producers such as the ABS to get more input from secondary users, because that will also put a bit of a pressure on us to improve our role in society to be helpful and share data in a safe way for community progress and research progress. And especially around quality frameworks, it would be good to have a user's perspective in there as well. On the other hand, it's also important that researchers follow these kinds of things to get high quality research out there. So there's a win-win situation here where we can collaborate better. The ABS data integration environment is an embryo of what I would call an evolutionary thing in the data landscape. So we're still, putting things out there, making data more available in a safe way, and keeping our commitment to protecting data, but at the same time making more use of the data that exists. And I think it's going to be a very interesting future ahead here of seeing how far we can actually go to solve these repurpose issues, access right, data granularity, metadata questions, and so on. And there's a whole community out there, not just in Australia, but also internationally, working on similar types of issues. And just as I said in the beginning, the poverty thing is actually an international question as well. So it's environmental issues and so on. It's going to be a big hunger and thirst for data sources that already exist to do these kinds of research projects and solve the objectives. I think that kind of wraps it up, what we wanted to say. I just want to say as well that the ABS will be very interested in hearing and getting collaborations, given that they are in line with our resources and objectives in this space. I also like to highlight and give a heads up for an upcoming seminar, which will be a little bit more into detail what we do at the ABS in terms of the data integration and where we sit in terms of future development process. So the next slide will be a set of references that we used in this presentation, and I think that kind of moves us on to a questions session.